Hey guys, I'm just introducing Przemek, our next speaker, on truly standalone Scala scripts. He's a Scala enthusiast with a Java background, and he's going to give us an awesome talk. So I'll hand over now.
Hi, everyone. I'm very excited to speak in front of you. It will be my pleasure to present you the first public release of a tool that I've been working on, which approaches the topic of Scala scripting in quite a novel way that I haven't seen done before. Just let me switch to my slides. And I guess you can see the slides right now. So, thank you. The first, I'm going to do a bit of introduction. Why did I even start to look at the topic? Why should one care about Scala scripting, actually? Because this is something that is, let's face it, not very popular. We've got some coverage in Scala tooling for it, but people choose other languages on the daily basis. So Scala is nowhere near popular for scripting as Bash and Python. And first, I would like to go over the state of the art in Scala scripting. How does it work right now? Why does one even want to use Scala for scripting? Then I will try to highlight some pain points that I've experienced and that motivated me to actually do something and create what I created. Then I'm going to present you the tool, which is called DSK, or the scripting kit. And I would demo it to you. I would show you how it works. And then I count on a fruitful discussion full of criticism, good ideas. So this is the part that I'm looking forward most to. And let me start. So this is how the Scala code ecosystem might be pictured. On one hand, you've got some tools devoted to exploration. You can use things like Ammonite REPL, Scasti, Polynode, Elmont, Scala Fiddle to run some short Scala snippets to learn how would Scala behave, what would be output of some experiment, to also process some chunks of data. And this is useful for learning. This is instant in editing and running. You simply go to like Scala Fiddle, type some Scala code, run it, you see the result. The code is often one-off. It can be often easily shared with others, but well, the usage of that code is limited. You basically run it within a specialized tool. Well, regarding the code structure, it has basically ad hoc structure most of the time. So on the other side of the spectrum is what Scala is known best from. So this is all big applications which involve akka clusters, usage of Kafka, distributed systems, big data processing systems, many enterprise applications that are rich in structure. You typically build a system for repeated use. It is certainly not a one-off thing. The systems perform big and complex tasks. So the development of such apps is very involved. You use basically build tools like SBT, Meal, Fury, numerous others. You carefully choose your dependencies, set of plugins that manage whole the life cycle of the app. And it is the most powerful form, but it's also with the most tax on you in terms of development overhead. And in the middle, there is scripting, which is for often small tasks, but the scripts have some simple structure and are meant to be used repeatedly. For example, some internal company automation. Sometimes you just need a script that would repeatedly upload some files to S3 bucket or to call some API in GitLab. If you've got script, you expect it to be easy in editing, running, and distributing. So what Scala has at the moment are mainly two things. The Scala REPL shipped with the Scala distribution, and also Ammonite scripts. So TSK, the scripting kit, is a newcomer to this area. And let me tell you why. So one of the pain points of Scala scripting is that Scala means most often JVM. This is something that everybody from Scala developers expects as something present on a system. We sometimes forget that there are some experts that are not into JVM, not into Scala, not into Scala tooling. And in many places, you simply don't have JVM, right? So for Scala scripting, JVM is a necessity. You need to have a JVM, you need to install a REPL, be it Ammonite or the other one, and then you are able to run scripts. So, well, you may ask, what's the deal? Give somebody an instruction how to install JVM, how to install Ammonite, and you're done. But you know, yeah, it isn't that difficult, but if you compare it to Bash, where you don't really need to install anything, you don't need to install rep, you simply edit some script and you run it. Then Bash simply wins. If the task is simple enough, there is no sense to even involve Scala. So similar in Python, Python installation and library installation is obviously mandatory, but often those things are on the target system. Python is quite popular. Also, it has a philosophy of batteries included. So standard library lets you do much stuff already. So often what you need is that you simply edit and run a script. So people go for Python and Bash much more often than they go for Scala, which is a shame because Scala is a great language and lets you write things that you can then evolve safely. So the other thing in Scala scripting is that scripts are not regular Scala. On one hand, this is a nice thing because you don't need to provide all the boilerplate. The REPL does it for you. You just write your code and it is automatically wrapped into classes. Also, you have magic imports in Ammonite that let you import whatever library you fancy. And some of the libraries are also shipped with Ammonite by default. So you simply import it. But this is a double-edged sword. If you are happy with your script and something happens that you start to want to upgrade it into a proper app, you are in a sort of a dead end, because you need to provide those all wrappers by hand. You need to sort out the extra dependencies, and also you need to rewrite magic imports into a build tool configuration. So here is where the TSK, the scripting kit, comes. The subtitle is Truly Standalone Scripts on Linux and Mac. I should add that it also runs on Windows WSL, Linux for Windows system. It has a GitHub project, and the idea is that you run Scala as if it were Bash. So let me demo the script. Here I will show you a simple program. It is called URL grep. The idea behind this program is to pipe some text to it, and it would just output the URLs that are within it. Let me simply show you how does it look like. So this is simple Scala application. And what happens if I run it? Echo, well, maybe curl. I'm piping the contents of Scala-lang site to the script. Notice that I simply use URL grep. And what happens is that compilation happens, and then all links, all URLs found in the sources of the page get displayed. So if I show you, the file has the execute permission, and it can be simply executed by bash. So you may ask, how does it happen? So let me show you. If I open the URL grep, the first line is a Scala comment, right? So all IDEs are happy about it. There is no something like magic import here. Well, this line is called a preamble in TSK vocabulary, and it contains out of shell commands. In this case, there are 4 shell commands separated by semicolons. You may ask, what is this one, right? So let me try to see. Home is directory. Root is the root directory. If I append second slash to the root, it is also a directory. What happens if I try to run something like this? It is an error, obviously. What happens if I do this? The error message will be suspended. So how does it work is that basically this is an invalid shell command, but shell doesn't care and simply goes to execute the other stuff. So the other command is sourcing of some shell code. So what happens here is that curl is downloading a short script, boot.tsk, which is TSK bootstrapper, executes it using sh, and the effect of the execution is a path to newly installed shell script on your disk, and this script is sourced. the script on the disk is TSK. TSK is basically a shell functions library. So when you source it, some definitions are introduced into the current scope. So the most useful definition is run. And run, how does it, what does it do? Is that it downloads Cursor, downloads Java development kit using Cursor, downloads all the required dependencies, downloads Bloop, compiles the script with Bloop, and then executes Java using exec primitive. So the whole script is replaced by Java. So normally the exit at the end isn't needed, but this is a last resort exit in case anything on the left-hand side would fail. So this is one case of the preamble that is simply designed to be easily used by whoever wants, even from memory, but you can do it in other way. For example, there is lots of people that oppose the idea of basically running curl and piping the output into SH. I will happily debate anyone who would object to this idea, but I know that there is lots of people that are allergic to it. So the alternative is that the TSK is already downloaded to disk, but then it also works, but it isn't, well, self-installable then. But, well, basically, you end up with a Java app, which is executed in basically very, very simple way. So to demonstrate you that this would work on a system that doesn't have Java, doesn't have anything, I will run this source into a Docker container with a fresh Fedora image. So Java, not found. Then let me simply save that script. Yeah, let me make it executable. And let me basically do something similar. And TSK will be working. It will take a couple of minutes because, as you can see, the JVM was not on the machine, so Cursor needs to download it. Now the Bloop needs to be downloaded. So let's give it a bit of time until it finally finishes. But in the meantime, let me demonstrate one useful thing. As I mentioned, TSK compiles the sources using Bloop. And what happens is that, oh, you can see it completed already. It was quite fast. I didn't expect that. And you can see that the next time you run it, everything is cached. Everything is compiled, etc. So we are basically fine. What TSK does is it generates Bloop config. So you can see the Bloop directory, and it is basically sufficient to get all IDE support that you would expect when you want to edit the script. So let me run code in this directory. Everything is highlighted properly. This is a valid Scala Bloop project, I can jump to the definitions. For example, here, let me try. Yeah, I am in sources, right? This is the central idea behind TSK. You prepend a special preamble that makes your script immediately executable. No installations of Java, no installations of any tools like Ammonite. It all happens in background. So now, if you work with some Python expert, who is expert in machine learning, but that person is not into Scala, not even into JVM world, and you want to give that person some short program written in Scala that that person would be able to run. It is not harder than just handing out this piece of text. Also, if you're a library author and want to show some examples of your library, you can make those examples instantly executable for your users. They would just download the examples, they would run them immediately on their machines. So that's
just really quickly, could you move your terminal windows up just a sec, slightly, please? Apparently, the prompt at the bottom of the screen is not visible.
All right.
Well, that should be better.
Oh, thank you.
Thank you.
Yeah, just to demonstrate, I would basically run any sort of site that you would like to see. Well, Carol. I'm picking this site because I know it contains lots of URLs. Not sure if google.com would work too. Maybe not, because the code is that, no, it actually had one link, right? The link is google.com. What is supported in TSK is the dependencies. This is the greatest part right now. Dependencies, you configure it using environment variable named, nomen omen, dependencies, right? So let me demonstrate that to you. So let me close the, oh, maybe let me not close it yet. Let me show you some other example. Yeah, I've got a HTTP server, right? Serve lines. Well, see what I did here. Previously, the preamble was just one line, but now it spans multiple lines. How did I did it? So the first part of the TSK preamble, I call it Scala compiler pacifier, because it causes the Scala compiler to not freak out when it sees shell commands, is the original line, but with escape near the new line. So the command continues to the second line. The second line is basically what Scala understands as an opening of block comment. And that way, we can easily have a preamble that can have multiple different entries. So just to give you idea, dependencies is the most important part. Here, I specified just one library, Cask, of Lee Haoi, who work I admire. I'm a great fan of Singapore stack, and I love this philosophy. I've used his library, and I specified Scala version. You can also specify Java versions. You can specify Bloop and Cursor versions that you want to use. it doesn't support the nice reproducibility options that Alex has mentioned on his talk. But thanks to the dependencies, well, the bloop configuration is basically done in a different way. Well, it just contains the dependencies. So if I run code here, I will show you that I would be able to go not only to the definition of standard libraries, but also to definitions of things that are within other libraries that are imported. So for now, I can see some problems, but let me check if, no, I can go to definition. I'm not really sure why is it displaying the problems. Let me try to refresh to make sure basically if this is the right, the config, the bloop config is up to date. I will run it by running the server. Serve lines basically serves the lines passed to it as a standard input. So maybe I will pipe this command to it. So in another window, I would need to use curl to get the first line, the second line, the third line, and so on and so on. So we can see that the server is running. Let me break it. Let me run the code again. If it still displays the red squiggles, then I will need to take a look. But hopefully, no. Yeah, I need to take a look what can be the reason, really. Let me try to open it in IDEA instead. Well, is IDEA finished? I think so. Yeah, IDEA is better for that case. IDEA doesn't display red squiggles. Yeah, I will need to investigate what is the reason. But well, since this is near the end of my talk, I would only want to tell you that similar like you have ability to split your scripts into several files, you also can do it in TSK, but you've got a special source variable where you specify where are the other sources. But I won't demonstrate it to you right now because lack of time. You can also use your own repositories. Like in company, you often have your internal repository for artifacts. So you can easily use your published internal libraries for scripting. Also, you can specify some weird proxy parameters for access to the repository. So this is fully working. And what I have in the plans for TSK is that you would be able to actually use GraalVM to compile your scripts into native binaries. So when you run your script, the compilation happens, and then the subsequent runs are super fast and have a tiny memory footprint and start up fast. So that is one of the plans. The other plan is that since you can see that the Scala code is normal one without all the magic, all tools are, well, basically expected to work with that without much problems. As you could see, it isn't always the case. but in my experience, it worked for me quite well so far. And it should be much, much easier to scale up your script into a proper application. So the next option that I want to add to TSK is basically export to mil config and export to SBT config. So if you created a prototype that initially didn't justify investment into all the software engineering things like build pipeline configurations, like even SBT, it was meant to be a throwaway, but it proved its worth over time. You would be able to easily upscale it to a proper application with a proper build tool, with all of that. So I want to do it. This is, in my opinion, important to be able to start small, to not invest much, but then to evolve it into a bigger thing easily. Apart of this, there might be a thing that would be needed to support Windows, but obviously Windows doesn't have a shell, at least not without Windows subsystem for Linux. I think about adding some TSK CLI app that could be used on Windows. I think that's it. Let me basically go to credits. So I really wanted to appreciate and say thank you to all authors and contributors of Coursera, Loop, Ammonite, Scala, JVM, and Unix. Also to all people that gave me feedback, and also to my friends from Hello Soda for supporting me, giving me feedback, and also providing me generous time in terms of 10% project time for doing that. And thank you. This is the URL of the project. I'm Przemek Pokrywka on Twitter. And I invite everybody to Q&A because